500 million years or so. So here, for instance, crisis number 6 is the Cretaceous tertiary boundary, extinction of the dinosaurs. So climate then is an important component of determining where and how carbonates form. Yeah.
So, is it relatively is it about right to say that whenever the Earth comes from an ice house to a greenhouse, that can still be an immediate extinction event?
No. Well, it's clear that climate affects biosphere, organisms. the mass extinctions that we were looking at in that previous slide, like the end Cretaceous, reflects an extinction that occurs over relatively short periods of time, very short periods of time in the case of the Cretaceous tertiary boundary. And the argument that climate, although it changes fairly rapidly, is probably not changing at a clip that would be high enough to necessarily account for that. Clearly, organisms respond to climate, but typically, if you make the changes slow enough, many organisms are able to respond and adapt, migrate, for example. Now, plants can't migrate, certainly trees and things of that kind, they can't migrate easily. And so, in that sense, there might be a relationship. And some of the extinctions that we see in the Phanerozoic are related to variations in the climate. But it's not a clear-cut, necessarily one-for-one relationship.
So it does contribute, it's just not.
That's correct. Yeah. Well, when you're in an ice house climate, ice caps are forming on the continents, and the water that it takes to generate those ice caps causes sea level to fall. Similarly, when you increase the temperature, you go to a greenhouse climate, you melt the ice caps on the continents, and that'll cause sea level to rise. Okay? Well, why did it change that? I have no idea. I mean, we went into the greenhouse climate prior to Jurassic transition. The point I was making in my big lecture that I teach is that the dinosaurs that were around then didn't drive SUVs, for example, and so there are causes, natural causes, if you will, that affect climate and the change of climate. And the change of climate that we are seeing today is in part due to natural causes related to orbital variations in the planet and all these other things, but also related to greenhouse gases, and of course people are generating huge amounts of greenhouse gases, so there are contributing factors. We know from looking at these kinds of graphs that the Earth's climate is very dynamic and it changes in a cyclical fashion through time, so that should not come as a great surprise. The question in the modern debate is how and to what level are we driving it faster than it might normally have occurred? That's the issue of debate today. Not that people say climate isn't changing, and that's nonsense. Of course it's changing, that's what climate does. It's always changing. The question is, what are the driving mechanisms? And so the question you asked is what happened here. I have no idea, but something obviously happened to cause that change. So climate influences where carbonates are deposited. They can be deposited in marine and freshwater settings. Obviously, well, perhaps not so obviously, but the reality is that the greatest volume of carbonates are shallow marine deposits, and the vast majority of carbonates tend to be autochthonous, there's that term, Remember, we talked about the loftiness sedimentary materials being brought from outside the basin into the basin. If the materials formed within the basin, they are described as being more proximate in nature. And this is an important point because it reduces the emphasis on hydraulic transfer of sedimentary particles. Because if you look at terrigenous sedimentary rocks, one of the things that you look at, for example, is grain size or particle size, because that reflects energy conditions needed to move grains. Larger grains need higher energy to move them than do finer grains. Well, when we look at carbonate rocks and the particles that we see with them, they form in place in the basin. And so if you have a large chunk of a carbonate particle, such as a oyster shell, that does not indicate high energy hydraulic transportation conditions. It merely reflects the fact that that chunk of calcium carbonate grew in place. Yeah.
Two questions. When you say most form in a shallow marine, what do you mean by shallow? Do you mean
10 meters or less.
10 meters or less?
Yeah.
Right.
But they can form in deeper waters than that, but the bulk of them tend to form in those shallow waters. And the deeper it gets, the lower the volume that's generated or is precipitated.
Also, with precipitated carbonates, larger particles or smaller particles don't give any boost on the energy level until it forms in place.
It's not that they don't give you energy information. You have to look at them carefully to recognize that they may not be the product of high energy or low energy.
Versus the other type of originals, you see what part.
Yes, you have to deal with higher energy. Yeah. So if we look at the various factors, environmental factors that affect carbonate deposition, they tend to form in warm, shallow, clear marine waters. So when you go on your vacation in the Caribbean, those nice waters are often the sites of carbonate deposition. Agitated water is important. Typically experiencing relatively high rates of evaporation, which would address warmer conditions, i.e. think back to the greenhouse climate argument, and a decrease in carbon dioxide concentration, which typically happens in shallower water. In deeper waters, carbon dioxide, by virtue of pressure differences, can be held in greater concentrations. Shallow waters with agitation and so on and so forth can result in the release of carbon dioxide. And so if you look around the world today where we see carbonates forming, here off the southeast coast of the US, we have the Bahamas platform, the white milky substance that we see on the Bahama banks are oolite shoals. You typically see carbonates formed either on isolated major offshore banks, of which this is one, or of course you can have a shelf that's attached to a continent, and it has a shelf margin that may be characterized by the presence of coral reefs of that kind. So the bulk of carbonates that we see forming today forming essentially what we can refer to as tropical to subtropical conditions, 30 degrees north and south of the equator, and in shallow marine settings, usually less than 10 meters in depth. Now, as I pointed out earlier, that doesn't mean carbonates can't form below 10 meters. Volumetrically, it's the upper 10 meters where you see a lot of the carbonates forming.